Thermal conductivity refers to the ability of a material, in this case, metal, to conduct heat. Metals are known for their high thermal conductivity, which means they can transfer heat efficiently compared to other materials. The reason for this high conductivity lies in their atomic structure. In metals, atoms are closely packed in a lattice structure, allowing free electrons to move around easily. These free electrons carry thermal energy, transferring it rapidly throughout the material. As one part of the metal warms up, the electrons in that area gain energy and move more rapidly. They then collide with neighboring atoms and electrons, passing along the heat energy. This process continues, enabling heat to travel quickly through the metal. Different metals have varying levels of thermal conductivity. For example, copper and aluminum are among the best conductors due to their high density of free electrons. This property makes them essential in applications where efficient heat transfer is required, such as in cooking utensils, heat exchangers, and electrical components. On the other hand, metals like stainless steel have lower thermal conductivity, making them less efficient but sometimes more desirable for specific applications that require resistance to corrosion or other factors. The measurement of thermal conductivity is typically expressed in watts per meter per Kelvin, symbolized as W/m_K. This quantifies how much heat energy can be conducted through a material over a given distance and temperature difference. Understanding the thermal conductivity of different metals is crucial in engineering, building, and manufacturing processes, where heat management is vital. For instance, in electrical engineering, selecting a metal with high thermal conductivity is essential for designing components like heat sinks that protect sensitive electronics from overheating. In construction, materials are chosen based on their thermal properties to enhance energy efficiency within buildings. Insulation materials often use metals with low thermal conductivity to minimize heat transfer, while structures may incorporate metals with high conductivity where heat is needed rapidly. The differences in thermal conductivity among metals also influence their usage in everyday products. For example, cookware is commonly made from metals like copper or aluminum due to their ability to heat evenly and quickly, ensuring that food cooks uniformly. Conversely, materials such as stainless steel or cast iron are often chosen for their durability and specific cooking characteristics, even if they conduct heat less efficiently. Additionally, metals are often alloyed with other elements to tailor their thermal properties for specific applications. For example, adding certain elements can enhance the thermal conductivity of a metal or improve its resistance to oxidation at high temperatures. This adaptability makes metals incredibly versatile in engineering and technology. Temperature affects thermal conductivity as well. As temperature rises, many metals exhibit increased thermal conductivity due to the increased energy and movement of atoms. However, this relationship can vary among different metals and is influenced by their specific properties. Furthermore, the concept of thermal conductivity goes hand in hand with other thermal properties, such as thermal expansion and specific heat capacity. These characteristics help in understanding how a metal will behave under heat, impacting everything from its structural integrity to its performance in specific applications. Thermal resistance is another important concept linked to thermal conductivity. While thermal conductivity is a measure of how well a material conducts heat, thermal resistance indicates how well it resists heat flow. Engineers must balance these properties when designing systems that involve heat transfer, ensuring that the right materials are used for optimal performance. In summary, thermal conductivity is a fundamental property of metals that determines how effectively they can conduct heat. This property is intrinsic to metals due to their unique atomic structure and the presence of free electrons. Understanding thermal conductivity is essential for selecting materials for a wide array of applications, ranging from everyday household items to advanced engineering systems, highlighting the importance of this concept in both practical and theoretical contexts. The efficient heat transfer capabilities of metals play a crucial role in advancing technology and improving energy efficiency in various fields.